Find the form of all vectors which are perpendicular to 3, 4. Are all of the vectors parallel? Okay, so if we're looking for perpendicular, a vector that's perpendicular to another vector, we think dot product. We think dot product equals 0. So basically 3, 4 dot something else needs to equal 0. Okay. And if you think about it, well, these are going to have to cancel out, and they're going to have to add to 0. You're going to need two things that are equal in size but opposite in sign. So we could have potentially a -4 here. So 3 times -4 would make -12, and 4 times 3 would make 12, right? Or we could have said, well, 3 and 4, and potentially then we could have had, well, 3 times +4 or 4 times -3 would have done the same job. So this is making the lowest common multiple of the 3 and 4, which is 12. But we could have, if say you double these two numbers, we could have had 3 and 4 dot, say 8 and -6. Should still equalize. 3 times 8, 24. 4 times -6, still 24, and so on. We could have tripled those numbers. So basically, all of these vectors, all perpendicular vectors, have the form where it's k times, and I can really write either of these, so I could write k times -4, 3, or k times 4 -3. I'll use the first one. And k, the only thing k cannot be is 0. K cannot be 0, because basically if k is 0, then you don't have another vector. You certainly, there's nothing to say that it's perpendicular. The other question, are all of these vectors parallel? Well, yes, they are, because when you multiply a vector, e.g. 4, 3, or -4, 3, sorry, by a scalar, that just makes it longer. It can change the direction if you multiply by a negative, but it basically makes it longer. So if k was 2, this vector would be parallel, but twice as long. If k was -1, it would be parallel, but it would go backwards. All of these vectors are parallel.